Good evening, guys. Today's Excel session is on uh, calculating the options, call option and put option pricing using binomial model. So we'll be covering both kind of options today. We'll be covering European option and American option as well. So let's see an example first. So the situation is they say consider a 3-period binomial model for a stock with a current price as not as $100. The stock does not pay any dividend, and what we are assuming, we are assuming that over each of the next 1 year period, the stock price can either move up by factor U, which is 1.2, or down by a factor D, which is zero point 0.8. And the continuously compound interest rate is 3% in period 1, 4% in period 2, and 5% in period 3. So these parameters has already been provided in the sheet number 2 as parameter. So S naught is $100, U is 1.2, D is 0.8, R1, R2, and R3 are 3%, 4%, 5% respectively. So they say that calculate the initial price of a European put option written on the stock with a strike price K is equal to 90 and maturity period is 3 years. So we need to calculate price of the European put option. So first of all, we need to see how's the payoff or how's the binomial tree is going to look like for this situation in the next 3 years. So you can see here, I have made a binomial tree diagram for this 3-period binomial model. So we start from t is equal to 0 as S naught. The price is $100. So at time 1, there are two possibilities. Either it can go up or it can go down. If it goes up, the price is 120, and if it goes down, the price is 80. And again, for time t is equal to 2, we have three scenarios. Either it will continue to go up and the price will be 144, or it will go down with price 96, or it will go up from this price 80 at a price of 96, or it will further go down the next year also with a price of 64. And similarly, for t is equal to 3, we have four situations. Either it will continue to go up, or either it will continue to go down, or it will have an up-down movement like this. So at time t is equal to 3, the price of the asset can be 172.8 or 115.2, 76.8, and 51.2. Now, since it's a put option, so we need to see under which scenario we are going to exercise this put option. So we can clearly see here that the strike price for this put option is $90. So as per for this strike price, we can see here these are the two scenarios where I will have a positive payoff for a put option. So in this situation, you can see here the price of the asset will be 76.8, and if I exercise my put option, so the payoff will be the difference between the K and the price, which is 13.2, or it will be exercised under this situation where the difference between the price and the K is 90, which is 90, the difference is 38.8. So you can see here the payoff for a put option will have a positive value under these two situations, and there will be no payoff under these situations because it is not going to fulfill the condition for the put option. So now our aim is to calculate the price at each node, and by doing this and working backwards, we need to calculate the price of the put option at time t is equal to 0. So we know that in the binomial model, we need to calculate probabilities first. The probabilities, the risk neutral probability of going up and going down. And since R1, R2, and R3, and for these three periods are different, so we need to calculate three different probabilities. So let's say for this period, the risk neutral probability will be e to the power R3 minus D upon U minus D. R3 is 5%, D is your 0.8, and U is your 1.2. So the probability value that you will get is 0.6281. Similarly, the risk neutral probability at this juncture will be e to the power R2 minus D upon U minus D, and R2 will be 4% for this scenario. The value will be 0.60202. And similarly for time period 1, you can have the value of Q1, which is e to the power R1. Again, R1 is a 3% minus D upon U minus D. The value is 0.576. So what we have done is we have calculated separately the risk neutral probability for each time period. And now we are going to see how we can proceed these with these values in the Excel file. So okay, so you can clearly see here I have first calculated all the parameters that I'll be requiring for this calculation. So it is e to this value is e to the power r1 minus r1. This is e to the power minus r2. This is e to the power minus r3. S naught is $100. K is 90. And the risk neutral probabilities which I have calculated here, Q1, Q2, and Q3. So I have used the same formula. So it is e to the power r1, and the value of r1 will come from from this parameter sheet at B7. The D will come from the parameter sheet B6 again, and that divided by U minus D. So the value of Q1, Q2, Q3 are these. Again, e to the power R2 minus D upon U minus D, and e to the power R2 minus D upon U minus D. And similarly, I've calculated 1 minus Q, which is nothing but the difference, the 1 minus this value. So same goes for these also. So I've calculated all the required values and parameters that I'll be needing for the calculation of the option price here. So let's start the pricing of the value of the contract at different time. So you can clearly see here. So at time t is equal to 3, there are four possibilities which can have in this contract. So we have write down all those values. So the moment UUU means all the values uh, from time 1 till time 3, the value of the share price has gone up only. So these are the next two possibilities, UUD or UDU, because there are many ways uh, to have these kind of situations. Again, for the same goes for the third situation, and there is only one scenario in which you will have all the downward values. So the share price under the scenario number 1 will be 172.8. Again, for the next will be 115.2, then 76.8 and 51. So correspondingly, the options value will be 0, 0 and 13.2 and 38.8, which has already been explained earlier. So now what we are going to do, we are going to calculate the discounted value, the expected discounted value of this payoff at time t is equal to 2. So now you can see here, if you clearly see the expected discounted value, expected present value of these two possibilities will be 0 because the option payoff is 0. So at this point, the value of the contract will be 0. For these two possibilities, there will be some value of the contract at this juncture as at this point. So that value will be nothing but e to the power minus R3, which is this value, into the payoff into the risk neutral probability. So you can clearly see here, when you go from this situation to this situation, the payoff is 0. So if you see the formula for the to calculate the value of the contract is e to the power minus r QCU plus 1 minus QCD. So CU in this situation is 0 and CD in this situation is 13.2. So it has to be e to the power minus R3 into Q0 plus 1 minus Q 13.2. So you can see here, I've done the same calculation, e to the power minus R3 into Q3 CU plus 1 minus Q3 into CD. And the value that you will get is 4.68668. And the same thing goes for the next thing. So it has to be e to the power minus R3 Q CU, yeah, Q3 into CU plus 1 minus Q3 into CD. So the value of the contract at time 2 is 0, 4.668 and 21.6106. So here the value will be 0, here it will be 4.66 and here it will be 21.68. So again we will do the same calculation at this point also. So you can see here the value is 0, here the value is 4.16. So the value of this option contract at this point will be e to the power minus r2 into QCU. CU again is 0 plus 1 minus QCD, and the CD value is 4.66. So you can see here it is e to the power minus r2 into q2 cu, which is 0, plus q1 minus q2 into cd, which is 4.668, and same goes for this. It is nothing but e to the power minus r2 into qcu. Cu is over 4.66 into 1 into plus 1 minus q2 into cd, which is 21.6. So the value of the option contract at time 1 is 1.78 and 10.96. And once you have the value at this point, you can again do the same discounting. You can use the same discounting formula to calculate the value of the contract at time t is equal to 0. And that value of the contract is nothing but the price of that option. So it will be q into cu. Cu is, I think, in this situation is 1.78 plus 1 minus q into cd, and cd in this situation is 10.96, and the value of q that you're going to use is 0.576, and e to the power minus r1 value will be 0.970. So using that formula, the value of the option contract that we are getting here is 5.50786, and this value is nothing but the price of the put option. So this is how you calculate the price of a put option or a call option using three-period binomial model, and the same thing can be reciprocated for n-period binomial model also. So the methodology is quite long because it's a discrete, the assumption that we generally take for a binomial model is that it will be a stochastic process with discrete state space and discrete time. And once the stochastic process is assumed using a continuous time basis, so in that situation, the Black-Scholes formula for option pricing comes into the picture. So I hope you can easily see how to calculate the value of the put option or a call option using a n-period binomial model. Thank you very much.